Hello. In this video, I am about to cover hill climbing algorithm. So basically, hill climbing is a variant of generate and test in which feedback from the test procedure is used to help the generator decide in which direction to move in the search space. Here, hill climbing is a variant of generate and test in which feedback from the test procedure. Here, you are finding the feedback from the test procedure and which is used to generate. Used by the generator decide in which direction to move in the search space. So in pure generate and test procedure, the test function responds with only yes and no. It here only two possibilities is where it responds to the correction as yes or no. So actually hill climbing is often used with a good heuristic function is available for evaluating states but with when no other useful knowledge is available. So this is the basic of hill climbing. So actually, hill climbing has three types. So algorithm is simple hill climbing, steepest hill climbing, and simulated annealing. So we will cover the first one. So simple hill climbing. The simple hill climbing is the simplest way to implement the hill climbing as it follows. So algorithm for hill climbing is evaluate the initial state. If it is also a goal state, then return it quick and quit. So first initial state you will evaluate. Then if it is a goal state, then the goal state you have found out, then you will return it and you will quit from it. Otherwise, continue with the initial state as the current state. If it doesn't satisfy the goal state, then you will continue and make it as a current state. So loop until a solution is found. If then it is a current state, then you will find the goal state as a looping the or else you will be making the decisions. So loop until a solution is found or until there are no new operators left to be applied in the current state. Okay, so there are conditions over here. Evaluate the new state. If you gonna evaluate the new state, then there are three conditions. If it is a goal state, then return it and quick as the same first one. If it is a goal state, then the goal state you have achieved, then you can return it and you can quit it. So if it is not a goal state but it is better than the current state, then make it a current state. If you have found an initial state and initial state is better than you what you have searched for, then you will make this search as a current state. If it not better than the current state, then continue in the loop. If it is this is better, that's why you have considered this as the current state. If it is not better, then you will continue with these states and you will be looping for search for the goal state or it will be a better state. So this is nothing but simple hill climbing. Now the steepest hill climbing. So in steepest hill climbing, a useful variation of it is a useful variation on simple hill climbing. Consider all the moves from the current state and selects the best one as the next state. Here you will find an initial state and you will find the another search state and make if it is a better one, then you will make it as a current state. Then if the current state is satisfying, then you will return it and come out of it because you have achieved the goal state. So algorithm for steepest ascent hill climbing is evaluate the initial state. First you will evaluate the initial state. If it is a goal state, if satisfy the functionalities of a goal state, then return it and quit. Otherwise loop it. Continue with the current state. So loop until a solution is found or until a complete iteration procedure as no change to current state, same as previous one. Now you have to assign the SUCC to be a state such as any possible successor of the current state will be better than successor. You will find a successor state as a state, then you will compare it for the next state whether it is better than this state or not. If it is better, apply the operator and generate a new state. You have to first apply this operator and you can generate new states. If the new state is better than this or if you find it as a goal state, then return it and quit or else loop it or else consider it as a current state or else compare it to successor. You have to compare it. If it is better than the successor to the state, if it is not better, leave the successor alone. If it better, set the successor to the state. You have consider the successor state. If it better than the successor state, then you will find the search state as a successor state or else you will come out of that state. So if the successor state is better than the current state, then set the current state to success. If the success is better than the current state, you have consider a new search state, right? So if it is better than the successor state, then you will make this state as a current state or else the current states to success state. So this is steep at ascent hill climbing. So in steepest axial hill climbing, there are three terms: a local maximum, plateau, or a ridge. So here, a local maximum is a state that is better than its neighbors, but is not better than some other states further away. So better than neighbors, but not better than some other states. Okay. So plateau is a flat area of the search space in which whole set of neighboring states have same value. So all the sets will be having the same value. This is called as plateau. Ridge is a special kind of local maximum. So local maximum, as you know, ridge is a special kind of local maximum as it is an area of the search space that is higher than surrounding areas. Its area is normally higher than the other search states. Okay, this is called as ridge. So backtrack, as a previous videos I said, it is searching for a loopholes. Okay. So the last one is simulated annealing. So before that, you have to find this example. This is the initial state: A, B, C, D, E, F, G, H. It is in this order. So you have to convert it into this goal state. Like, what are all the decisions you are using to convert this into goal state is called as intermediate goal state. Okay, first you will consider the initial state. Then these are the decisions. Like H, A and H, you will keep it down and move this H to upside, and again you will come down with the A and H. Now you will bring A to down and H to up. For that, the goal state is being achieved. So these are the intermediate state decisions that you are taking for achieving this goal state. So next is simple annealing. So sorry, simulated annealing. So the idea is to do enough exploration of the whole space early so that the final solution is relatively insensitive to the starting set. So you have to explore to the whole space early. So the relatively insensitive to the string set is the solution. Okay. Here you will find a term P equals E det E of T. So this is the simulated annealing. So in this algorithm also, we have some conditions. So the annealing schedule must be maintained. Annealing schedules must be maintained. Move to worst states may be accepted. If the states is moved to worst, then it should be accepted. So it is a good idea to maintain in addition to the current state. So if the maintenance is okay, then it is a good idea for the current state. Okay. So algorithm for simulated annealing is, as I said, evaluate the initial state. Then if it's a goal state, then return it or quit. Then again continue initial state as a current state. Second one is initialize best so far to the current state. In previous you had took successor state. In this state you will be choosing best so far to the current state. So initialize T according to the annealing schedule. T is a term which has to be initialized by the annealing schedule. So loop until a solution is full. You will consider the initial state. Then you will be looping it until you found a new operator. So to be applied in the current state. So select an operator that has not been applied to the current state and apply. Check whether it satisfy the goal state or not. If satisfy the goal state, then you will make it as a current state and conclude as a goal state, or else you have to loop it. So evaluate the new state, then det of E equals value of current minus value of new state. This is the equation where you can find in this simulated annealing algorithm. So if it is a new state, then if the new state is a goal state, then return it and quit. So you can finally, if the goal state has been achieved, then you will return it and quit. So if it is not a goal state but better than the current state, then you will make that state as a current state. Best so far is the new state. Okay. So but if it is not better, then you will make the current state with probability of P dash, with probability of P dash as defined above. So this is the above where this is the above formula. P dash equals E minus det E divided by T. So you make in this form. So this step is usually invented by invoking a random number generator to produce a number in the range of 0 comma 1. Here binary is there. It is not like it is a binary, but it will be produced in a number of range 0 comma 1. If that number is less than P, then the move is accepted. Otherwise, do nothing. You can't even change the state, whether to goal state or current state. Then revise the T as necessary according to the annealing schedule. Return best so far as the answer. You will consider the best so far as a current state, then you will return as the goal state. Return best so far as the answer. This is called as simulated annealing algorithm. Thank you.